We're going to move on to using stoichiometry to help us predict what happens in a mixture of solutions, right? If we do have these dilutions, or if we have these mixtures and we're looking to form a precipitate, now we're going to take that into account with stoichiometry. So this says calculate the mass of lead sulfate formed when 1.25 liters of a 0.05 molar lead nitrate and 2.0 liters of 0.025 molar sodium sulfate are mixed. That sounds like a lot, right? That's a lot to take in. So first thing we have to do is build and balance a precipitate reaction. Okay, build and balance and figure out what's our precipitate going to be. Considering that it asks us to calculate the mass of lead sulfate, I'm going to take a guess that lead sulfate is our precipitate, but we still need to build and balance because we need to have mole ratios here. Okay, so let's build and balance here with our reactants. Reactants are lead 2 nitrate and sodium sulfate. Okay, so lead plus 2 nitrate, what would that give me? PB
NO3 parentheses plus 2.
Yeah, parentheses 2. Right? Lead nitrate. I'm going to make this a little smaller. Okay. Lead nitrate plus sodium sulfate. So sodium sulfate would have to be Na what?
SO4. No, Na2.
Good. Na2SO4. Now let's look at our solubility rules and figure out, are both of these going to be aqueous?
No, I think
Yes, reactants have to be.
Our rules anyway. Nitrates are soluble. So this one, lead nitrate, has to be aqueous. Okay, that's rule number 1. Number 2, sodium sulfate.
Sodium is in group 1.
That's right.
Not one of the exceptions for the sulfate.
That's right. It actually works with both rule 2 and 4. So this is
one of them doesn't.
No
Or does
chart.
that ever happen? Then it's solid.
yeah. If it doesn't work, then if one of them, if it would have been in the sulfate exception part, then that means it would have been solid. Okay. So one of our products is going to be lead 2 sulfate. That would just be PbSO4 because they balance. And it's asking us for mass, so we assume that's our precipitate, but let's just check that sulfate except for PbSO4. So this is going to be our solid. And then our final one would be what?
NaNO3.
Good. NaNO3. Okay, so let's balance that.
I think all chemistry should be done as a Gregorian chant.
Just a 2 here. NaNO3. Okay, here. NaNO3. So now we've got to start looking at how would we figure out how much product is made. Okay, first and foremost, this is still a chemical reaction, and we have 2 starting amounts, right? We have the starting amount of lead nitrate, and we have the starting amount of sodium sulfate. So what does it mean when we've got 2 different starting amounts? You're going to have a limiting reactant, right? We're going to have to find a limiting reactant here. Okay? So we're not given grams of each of these to start. What information are we given for each of these? Molarity and liters. So let's go ahead and look at each of these. Lead nitrate starts with a concentration of 0.05 molar equals moles over 1.25 liters. So this would be moles of lead nitrate. So 0.05 times 1.25, we get 0.0625 moles of PbNO3 2. Okay? And with our second set of reactants, sodium sulfate, we started with 0.025 molar equals moles over 2 liters. And that gives me 0.05 moles of Na2SO4. Okay? So now we've got to figure out which is our limiting reactant. I want you to look at the mole ratios between our products and our solid. I'm sorry, our reactants and our solid. Isn't that one 1-to-1?
Yeah.
And is this one 1-to-1? Right. So we could run the stoichiometry table, but we don't have to do two because since they're both 1-to-1 ratios, if I put in this many moles of lead nitrate, I'm going to get out this many moles of lead sulfate. And the same thing is true here. If I put in 0.05 moles of sodium sulfate, I would get out 0.05 moles of lead sulfate. So which of these is my limiting reactant? Lead nitrate or sodium sulfate? Right? This has to be my limiting reactant. If you still were unsure of that, you would just do the stoichiometry steps to go from moles of one to moles of my product. Right? You would just do the stoichiometry that goes from moles of each reactant to moles of your product. You don't have to go all the way to grams. You could, especially since it asks us for mass eventually, but I would go ahead and do this. 0.05 moles of Na2SO4.
Wait,
Wait, I thought you had to do both because they're molar mass.
Okay, so that's what I'm saying. You can do both. But since we see that everything that we're looking at here is a 1-to-1 ratio, our T-charts would be all 1-to-1.
But
Okay, let's go ahead and do it, and then I'll show you what I mean here, okay? So let me make this first part a little bit smaller, and then I'll show you what we're talking about. Let me give myself some more room here. All right, these are the amounts of starting material that we have. So let's say we couldn't figure out our limiting reactant. We weren't sure by looking at it. So I would go for each of them, 0.0625 moles of PbNO3, 2. Get rid of moles of that and go to moles of my product. Right, lead sulfate, PbSO4. Okay, it also asked for grams, so I might as well, while I'm here, go all the way from moles to grams of PbSO4. Okay, the mole ratio here of lead nitrate to lead sulfate is just 1-to-1, right? Because in our balanced reaction, 1 there, 1 there, right? Are we on the same page so far? Okay, so moles of lead sulfate, PbSO4, to grams. I don't know, does anyone have that molar mass calculated?
no.
good job, James.
Thanks.
What'd you get? 303.2. All right, so let's go ahead and calculate that all the way out. Times 0.0625. And that gives me 18.95 grams of my product that could be formed, right? That's one option. Now we do the same thing for our other reactant. We start with 0.05 moles of Na2SO4. We get rid of moles of that, Na2SO4, go to moles of lead sulfate. It's a 1-to-1 ratio, right? Because neither of them have a coefficient in front of them. And I go moles to grams. That gives me 303.2 times 0.05, 15.16 grams. Okay, so still we get the same conclusion that this is our limiting reactant.
So you don't ever have to do the molar mass of the two reactants?
No, because we're not starting with grams of our starting amount. We were starting with a solution of our starting amount, and so we were able to calculate moles of each of our starting amounts. So there we can go directly to mole ratio step. Okay? The only time we really saved by determining our limiting reactant early is that we could have just done an easy conversion and said, we know we're going to get 0.05 moles of PbSO4, and we did moles to grams there, right? That's the time that we saved. We would have been able to see that we were going to form this many moles, and we would have gotten 15.16 grams of lead sulfate a little earlier. Okay, the only time you can really look at that is and see it is if the mole ratios are the same, and in that case it was. Okay, if you're not sure, then yes, by all means, you do both of the tables and figure out what's your smaller amount of product formed. Okay?
You can always
Find the mass of solid NaCl that must be added to 1.50 liters of 1 molar solution of silver nitrate to precipitate the max amount of AgCl.
So we're gonna have solid on both sides.
Yeah, well, the NaCl will become aqueous. It's like saying how much of that do we need to find. So we're going to basically look for moles of that sodium chloride, and then we can convert it back to grams. Okay? Let's build and balance first, though. Okay? We're going to take sodium chloride, add it to silver nitrate. So this means NaCl plus AgNO3 yields AgCl, and then our final product would be sodium nitrate. All right, here's the information we were given. We were given 0.1 molar and 1.50 liters here. And that's really all we know so far. Okay? So what can we do with that information?
Determine the grade.
We can determine the number of moles of this. And it says to precipitate or to yield the maximum amount of AgCl. And so when the question says that, all that really means we're trying to figure out is if we want to use up everything that goes in from the AgNO3, how much salt do we have to add with it, right? That would give us our max precipitate. So it's just basically saying if we put in this much silver nitrate, how much salt do we need so we can get out our maximum amount of product, right? So it's kind of like this is the limiting reactant right now, okay? So if I take 0.1 molar equals moles over 1.5 liters. 1.5 times 0.1 gives me 0.15 moles of AgNO3, right? So that's how many moles are going into the solution. And so now I'm just going to do a stoichiometry problem basically to figure out if I want to use up all of this, how much NaCl do I need? Right? That's pretty much it. If I want to use up all of that silver nitrate, how much sodium chloride do I need? So I'm just going to start my stoichiometry chart with 0.15 moles of AgNO3. Moles of AgNO3. What am I going to go to?
Can't you just go straight to the
Yeah, moles of what?
AgCl.
No, we don't really care about AgCl because it's not asking us how much silver chloride we can. We're going to go NaCl because we want to know how much sodium chloride we need. So then we go moles of NaCl to grams of NaCl. Okay, and in this case, again, our mole ratio is 1:1. So we could have been able to tell right away that we were going to need 0.15 moles of NaCl, right? We could have saved ourselves some time and saw that right away. It's okay if you didn't, but we could have. But now we're just going to go ahead and plug it all the way in. So this one's 58.5. And so I got a mass of 8.78 grams. Right? This question is not asking what is the maximum amount of silver chloride that could be formed. Right? That's not what it's asking. It's asking how much salt has to go in with this solution in order to produce the most silver chloride we can. We could also calculate how much silver chloride could be formed just by doing another chart from the amount of silver nitrate we have to silver chloride. but that's not what it asked. Okay, so you got to really break down and think about what is my question asking. And then again, I would probably encourage you to write your information kind of above the reaction like that. It'll kind of help you zone in on what numbers go with what chemical formula and stuff like that, because sometimes that can be confusing if there's so many numbers listed in the problem, right? Try to give yourself a little bit more organized within that problem, okay?
How do you figure out what the question is asking? Like, are there any good ways to...
I would just start breaking the question down into like its individual parts. So it says, find the mass of NaCl. So I could have even come over here and done question mark grams, right? To really even like focus in on, my goal is to get to grams of sodium chloride. Okay. And then I was given this information right here, and I wasn't really asked anything about AgCl. Right? So that's not something I end up using in my problem at all. So I would just break it down by pieces of information you're given, and then things that you're not given or not asked about, then we get rid of them. Okay? All right, let's go ahead and try. Why don't you try this one on your own? Okay? Try this one on your own. That's what I got when I built. I haven't balanced it yet, but
Yep, that's what I got.
um,
I just haven't.
Imagine writing NaNO3 twice. Couldn't do that. Like you wrote it once first, and then wrote the left one, and then the
Okay.
Yeah.
I think this is what I had when I balanced it. 2316. No.
That's what I thought.
Drinking and driving is illegal, but I think you can.
I think eating and driving should be illegal.
Make smart decisions.
I think it's not encouraged.